Back to the exam review, problem 13a. We're solving absolute value equations here. And the most important thing to remember with an absolute value equation is that you have two cases. The case where what was in the absolute value signs was negative, we took the absolute value and made it positive, and the case where what was in the absolute value sign was positive, and when we took the absolute value, it was still positive. So I'm going to start with case 1. And for case 1, I'm going to take what was in the absolute value sign and set it equal to exactly what I have right there. This is the case where what was in the absolute value sign was positive. And I'm just going to solve that equation. So I add 5 to both sides. And that gives me 2x equals 14, divide 2, and x is 7. And then for the second case, I'm taking what was in the absolute value sign, 2x minus 5, and setting it equal to negative 9. That's saying that it was, before I took my absolute value, it was equal to a negative 9. So I'm going to solve this case. I add 5 to the other side again. Add 5 to negative 9 and I get negative 4. Divide by 2 and I get x is negative 2. So my solution set is x equals negative 2 and positive 7. And to check those, remember, you just plug back in. So I'm going to start with negative 2. I have 2 times negative 2 minus 5 in my absolute value sign equals 9. 2 times negative 2 is negative 4 minus 5, which is absolute negative 9 equals 9. And of course that gives us 9 equals 9. So that case worked just fine. When we check the other case, I have to check 7. So I have the absolute value of 2 times 7 minus 5 equals 9. 2 times 7 is 14 minus 5 is 9. And of course the absolute value of 9 is 9. So both of those cases worked. Now I'm going to move on to B, where I have the absolute value of 6n plus 18 plus 12 equals 8. Remember that the first thing you have to do in an absolute value equation is isolate your absolute value. I didn't mention that on A because it already was isolated. Here it's not. So the first thing we want to do is subtract 12 over to the other side. And that gives me the absolute value of 6n plus 18 equals negative 4. So let's think about this one a minute before we begin. If I have the absolute value of 6n plus 18, no matter what n is, once I multiply it by 6 and add 18 to it, then take the absolute value, the answer is not going to be negative because an absolute value has to be positive. So that tells me that there's no solution to this equation. Without even doing any work, I can see that there's no solution. And of course, I don't really mean positive when I say it's positive. Absolute value stands for the distance, not the direction. So it's not really positive, but we tend to call it positive even though we know it really isn't positive or negative. Okay, so that has no solution. Now, if I began working that and trying to solve it, what would happen is I might get solutions, but when I plugged them back in, it wouldn't work. So the idea is that you recognize that when I take an absolute value, whatever is in the absolute value sign, it is not going to be equal to a negative answer. So no work to do for that one. Okay, now I'm going to solve an absolute value inequality. It says that we should graph the solution set and also write it in interval notation. Remember, these are absolute values, so there are always two cases: the case for where what was inside the absolute value was positive, and the case for the situation where what was inside the absolute value before you took the absolute value was negative. So I'm going to start with the positive case, case 1. And for case 1, I take what's in the absolute value sign, 2x plus 1, and set it equal to, or actually unequal to in this case, what I have on the right-hand side. So that's less than or equal to 17, and then I just solve that. I have 2x is less than or equal to, I subtract 1, and I have 16, and I have x is less than or equal to 8. And now, this is a less than problem, and remember, less than is and. So I now have to solve it for the case where what was in the absolute value sign was negative. So for case 2, I have 2x plus 1, and I need to take the negative over to the right-hand side, and that's like dividing by a negative, so I have to change the direction of my inequality and change the sign, because remember, what was over here was negative. I took the negative to this side, and now I solve this case. So I have 2x is greater than or equal to negative 18, divide 2, and x is greater than or equal to negative 9. So it also says we need to graph the solution set, so I'm going to draw my number line, go from the least to the greatest, negative 9 and 8, and remember it's an AND case, and if it's an AND case, that means that I have to only graph on my number line the overlap of these two cases. So greater than or equal to negative 9 would start here and go in this direction. Less than or equal to 8 would start here and go in this direction. Again, it's an AND problem, so it's an overlap problem. So I'm graphing between negative 9 and positive 8, just where the two graphs overlap each other. And there's the graph. And writing it in interval notation, it begins at negative 9 and goes to 8. Both endpoints are included because of the equal signs there. That's my solution in interval notation. Now, that's what I do if I take this and make two separate cases out of it. I could turn this around and rewrite it as just one case. So let me show you that way. Okay, I've written that compound inequality as one compound inequality instead of two separate inequalities. Remember what we did before was we took the case, lost my pen there, took the case where what was in, get my pen back, where I took what was in the absolute value sign and I set it less than or equal to 17, and I have that right here. The second part of that was I changed the direction and made it negative. So this was greater than negative 17. This is greater than, if you're reading it from the right to the left, is greater than negative 17. So if I turned that part around, the 2x plus 1 is greater than negative 17. It becomes negative 17 is less than or equal to 2x plus 1. So I've written it as one compound inequality, and now I solve it by moving away from the inside out in both directions. So I'm going to subtract 1 everywhere. That gives me negative 18 is less than or equal to 2x, which is less than or equal to 16. And now divide everything by 2. And I have negative 9 is less than or equal to x, which is less than or equal to 8. So now I don't have to look at my two separate inequalities and figure out what the direction on each one is when I graph it. I can clearly see that x falls between negative 9 and positive 8, and that's what I'm going to graph. Everything that falls between negative 9 and positive 8. And if you looked at that other graph, I had exactly the same thing, but I had to graph the two pieces on top first before I got there. Here I can see exactly what my two pieces are. So my interval notation would also be exactly the same solution. I think this way's a little bit easier, but some people find it a little tricky to turn this around and put it in front. But if you can do that, you're good to go.